Well, good morning, everyone, and welcome to today's Alaska Collaborative on Health and the Environment webinar. Today's session is entitled Per and Polyfluoroalkyl Substances, commonly referred to as PFAS, in breast milk, findings of a new study and policies needed to protect future generations. My name's Nick Reardon, and I'll be hosting today's webinar on behalf of Alaska Community Action on Toxics. I'm calling in from our office today, a nice change of pace, here in Anchorage, Alaska. And these are the traditional and unceded lands of the Dena'ina people. And so I'd just like to take a moment to acknowledge and thank the stewards of the place that I live and invite you all to do the same for the many places you, our listeners, all call home. CHE Alaska is a regional partner of a national collaborative on health and the environment organization. So that's the abbreviation CHE. And together, CHE and CHE Alaska work to advance knowledge as well as action around growing concerns associated with links between human health and environmental factors. So you can check out our websites to learn more. There's akaction.org and healthandenvironment.org. So this session will last an hour we have 3 guests today presenting, followed by 15 or 20 minutes of Q&A. So feel free at any time to type questions into the Q&A. There's a button located at the bottom of your screen. It's not distracting to us, so feel free to chime in at any point, and we'll get to those. I'll moderate those questions at the second half of the call. So as a bit of background, we're joined today by 3 of the authors of a recent study where 50 breastfeeding mothers in the Seattle area were shown to have the toxic substances known as per and polyfluoroalkyl substances, or PFAS, in their breast milk. And so while the women in the study reside in Washington State, it raises concerns in Alaska and everywhere, since here in Alaska, at least, we have 10 communities that have PFAS in their drinking water at levels deemed unsafe by the EPA. And PFAS has been found in the water of over 30 Alaskan communities. Long story short, in Alaska, the use of PFAS-based industrial firefighting foams on military bases and airports has contaminated the drinking water of certain communities throughout the state. And it's likely that the number of communities with contaminated water will grow as more sampling is conducted. Concern grows even more as it becomes increasingly clear that PFAS are not only contaminating groundwater and surface waters, but also the fish, the wild game, your garden produce, or even backyard chickens, etc. There's even been closures of several lakes in Alaska to fishing as a result of PFAS contamination. So I hope that background helps highlight a bit about why we think this recent study is so important, and why we're so grateful to our guests for their work and for taking the time to join us today. So now I'd like to introduce the speakers. Erica Schrader is the science director at Toxic Free Future, where she leads Toxic Free Future's research program with a focus on the uses of toxic chemicals in consumer products. And we're also joined by Dr. Amina Salamova, an associate scientist at the O'Neill School of Public and Environmental Affairs at Indiana University. And Dr. Salamova's research centers around determining exposure sources of well-known and emerging chemical contaminants, as well as on developing effective interventions to prevent or reduce these exposures. Our third guest and speakers is Dr. Sheila Satyanarayana, who is an associate professor of pediatrics at the University of Washington, where she also practices pediatric medicine and currently serves on the US EPA's Scientific Advisory Committee on Chemicals for the Toxic Substances Control Act. And now I could go on and on about these 3 individuals' accomplishments, but in the interest of time and in the interest of hearing from them and about their work, I'd like to welcome all of you and thanks so much for joining us here today, and I'll pass it off. Yeah, take it away.
So this is Erica. I'm going to be starting off with a kind of an introduction and background about PFAS. And then I'll hand it over to Amina and then Sheila and back to me ultimately, talking more about the study and what its implications are. So as Nick said, this was a collaborative project between Toxic Free Future, Indiana University, University of Washington Medicine, and Seattle Children's. And I wanted, before I get into the background, I want to take a minute to acknowledge our other co-authors who aren't here today. Guomao Zheng from Indiana University was the lead in doing all the analysis. Jennifer Dempsey and Nancy Uding took the lead in the participant recruitment and sample collection. Valerie Chu worked on the literature review, and Gabe Andres helped on the data analysis. So I'm pretty sure that we have kind of a wide range of background in this audience about what PFAS are. So for those of you who are already experts, please bear with me. But those of you who are not as familiar, I want to make sure that you understand the basics about PFAS and what we're talking about today. So PFAS stands for per and polyfluoroalkyl substances. It is an extremely large class of chemicals. We know of about 9,000 now. And I'm going to highlight some of the primary use types. One are fluorinated plastics. These are polymers like Teflon. And then other kinds of PFAS are used as processing aids to make those fluorinated plastics. And the pollution that was caused in that process is highlighted in the movie Dark Waters that I show here in the graphic. PFAS are also used as surface coatings, and as Nick said, in terms of firefighting foam, as surfactants. So, there are so many different kinds of PFAS, but I'll highlight some of the classes here that have been the most well-studied and found in the environment and in our bodies. So one is the carboxylates, and PFOA is the most well-known of those. It's depicted in the upper left-hand corner there. And it was widely used to produce fluoropolymers like Teflon, or also known as PTFE. And for the carboxylates, they've been considered to be long chain compounds if they have 8 or more carbons. So for example, PFOA is an 8-carbon compound. Another class are the sulfonates. So these are ones that contain sulfonic acid or a sulfonate group. PFAS is the best known among these, and that's depicted in the upper right-hand corner. The sulfonates, the long and short chain definition is a little bit different. What people generally do is to call sulfonates with 6 or more carbons long chain. So there's a lot more to the story to that, and I really recommend the paper called Never Ending Story of Per and Polyfluoroalkyl Substances by Jianyun Wang and others that was published in Environmental Science and Technology. And I showed the graphic from that study, which really does a great job of kind of explaining the different kinds of PFAS and increasing our understanding that there's a lot that we still don't know. I'm going to go through some of the main concerns that we have about PFAS, starting with persistence. Because, as you saw, these chemicals are fluorinated organic compounds, and the carbon-fluorine bond is the strongest in organic chemistry. So these end up being highly persistent compounds, and all PFAS are either or degrade into these persistent end products, similar to PFAS and PFOA. Once they get there, there's no known environmental degradation, and they're very difficult to destroy. So as we continue to produce PFAS, we're creating ongoing contamination. In addition, unlike many persistent bioaccumulative toxics, PFAS are actually highly soluble and mobile. So because of those properties, because their solubility in water, many can move through soil to groundwater. And as a result, we see now that an estimated 6 million US residents have their drinking water contaminated above EPA health advisory levels. I'm sorry that this map doesn't show Alaska. It's from the Who et al. Paper, which I also recommend as a good read about how the use of PFAS has contaminated drinking water. And we also know that the PFAS that are currently used, so primarily those short chain and other compounds, many of them are more mobile than the phased out compounds like the long chain PFAS and PFOA. We're also very concerned about the toxicity of PFAS because it can have health effects at low levels of exposure. And the ATSDR put out this toxicological profile earlier this year. So if you want to dive deep into what we know about the toxicity of these compounds, it's a great place to start. And I've summarized the findings from that profile. So in terms of studies in people, the PFAS that have been well studied, and that's a small group of PFAS, they've been associated with cancer, depression of the immune system, pregnancy-induced hypertension, and high cholesterol. And then in addition to those toxic endpoints, what we see in laboratory studies is that those same well-studied PFAS have been associated with toxicity to the liver, developmental toxicity, and effects on the immune system. We don't know as much about the PFAS that are currently used, but we see in laboratory studies that they're associated with effects on the kidney, liver, and thyroid, as well as developmental toxicity. Unfortunately, with PFAS, we see that throughout its life cycle, or as we like to call it, the path of pollution, there are exposures. And that begins with PFAS manufacturing. We unfortunately know from several areas around our country where PFAS have been manufactured, that has led to severe contamination in those communities, and including in drinking water, as well as harm to workers. Then the next step, when products are manufactured with the PFAS, we see additional contamination of the community and workers. And then when those products are used, we add consumers to that. We see contamination of house dust and indoor air during the use phase of those products. And then at the end of life, these products can go to landfills, to incinerators, to compost, and we see that they become an ongoing source of contamination. I'm going to highlight, the PFAS have many, many uses. I'm going to highlight just a few that are a little better understood than others. So one is food packaging. PFAS can be used in a couple of different ways to provide oil and grease resistance in food packaging and kind of takeout container uses. So one is as a surface coating for things like this popcorn bag or that wrapper you see on the right. PFAS can also be really mixed into the paper to make molded fiber containers like you see in the middle. Firefighting foam is another important use, and PFAS are primarily used in Class B foams, which are the ones that are intended to be used to be put out oil fires. So the primary uses have been at places like airports and refineries, where you might expect to find an oil fire. And they've been used extensively in training, as well as in emergency situations. In either case, those are uncontrolled releases in most of the time, and that's resulted in contamination of drinking water. The final use I wanted to highlight is textiles. They're used for steam protection and water resistance in carpet, in apparel, and in furniture and other home furnishings, so upholstery as well as other home furnishings. And they're applied in a couple different ways, mostly as surface coatings, but then in some applications, there's also a polymer membrane made of PFAS, so that could be in things like firefighter gear, as well as raincoats. And what we've learned is that when the PFAS are used in textiles, they actually, the products actually shed the PFAS over time, and they can build up in our indoor environments. So what we see as a result is that we're exposed from multiple different product sources, and there are multiple routes of exposure. This graphic is one that we prepared for the paper, and it highlights some of those product sources that would be in our home, school, or workplace. The major routes of exposure are through food, drinking water, indoor air, house dust, cord blood, breast milk. And with that, I will pass it on to Amina to talk about our study.
Thank you, Erica. Nick, can you hear me okay?
Yeah, I can hear you well. And it might help to, click the presentation mode for PowerPoint, it'll make the slides perfect.
Mm-hmm. So, hi everyone. I will be talking today about the results of our study on PFAS in breast milk. And here our general interest of our group was in early life exposures. And early life exposures are important because they can resonate later in life and may lead to adverse health effects. And breastfeeding is one of the important early life exposure pathways for nursing infants. So when we started looking into studies on PFAS contamination in breast milk, we found that there is really not much, especially in the US. The last 2 studies on PFAS in breast milk from the US mothers date back to 2004. So our study was really the first in the last 15 years that looked at PFAS in breast milk from the US mothers. Our concern here was to evaluate the current PFAS exposure pattern, because there were a few recent studies from Asia that have reported buildup of the current use PFAS in breast milk, which are deemed to be less bioaccumulative, and they are used as replacements for the legacy PFAS. So for this study, we've recruited 50 first-time moms residing in or near Seattle, Washington. That was done in 2019, and the recruitment was led by the great team at Toxic Free Future. We've recruited moms through parenting groups, social media, paper flyers. We've asked mom to manually express about 50 ml of breast milk into provided pre-cleaned glass containers, and we picked up the milk within 24 hours, and we've kept it frozen until it was shipped to the lab for the analysis. So our cohort was quite homogeneous. About 95% of our moms were Caucasian. The mean age was about 34. It ranged from 24 to 42 years old. And the residence time in Washington was on average about 13 years. Our moms, 94% of our moms had higher education, and 82% belonged to middle class or upper middle class. So the samples were shipped to the lab and analyzed. I'm not going to go into the details of the analysis. You can refer to our paper that was published in ESNT in May of this year. Briefly, the samples were analyzed using liquid chromatography tandem mass spectrometry for 39 PFAS, and this included, of course, PFAS and PFOA, long-chain PFAS, defined here as PFAS with 9 to 16 carbons, so C9 to C16, short-chain PFAS, defined here as C4 to C7, and several PFAS precursors. So, onto the results. PFAS were detected in all of the samples. In fact, each sample had at least one PFAS detected. Out of 39 PFAS, 16 were detected in the samples, and 12 were detected in more than 50% of the samples. Total PFAS concentrations, which are defined here as the sum of all the 16 PFAS detected in the samples, ranged from about 50 to about 16 picogram per mil. And you can see from this plot here that the majority of moms had concentrations varying between 100 to about 300 picogram per mil. Then a lower portion or had about 50 to 99 picogram per mil. And then a small number of moms had concentrations exceeding 300 picogram per mil. So this is a plot showing the concentrations for those individual PFAS, the 12 PFAS that were detected in more than half of the samples. And in fact, this PFAS were detected in 70 to 100% of the samples. The concentrations here are shown as box plots, and they represent the 25th and 75th percentiles, and the black line inside the box represents the median. The letters on the x-axis show the results of the ANOVA test, which was performed to compare the concentrations of individual PFAS among each other in order to find the most abundant and the least abundant compounds. And the boxes that share the same letter are not statistically different from each other, and the concentrations increase in alphabetic order. So the highest concentration would be labeled with A, and the lowest in this case would be labeled with F. So when we look at this plot, which is grouped into short chain, long chain, and the C8 PFAS, we can see right away that the highest concentrations were found for the usual suspects, PFOS and PFOA. The median PFOS concentrations were at about 30 picogram per mil, and the median PFOA concentrations were at about 14 picogram per mil, and they were found in all of the samples. So this finding was not surprising to us, because this is a pattern which has been seen in previous studies on breast milk and in other biological samples, because we know that PFOS and PFOA are very persistent, very bioaccumulative. They've been used for a long time. So seeing them at the highest levels found in these breast milk samples is not surprising. However, what was surprising to us is that along with the C8 compounds, we also found several, in this case, 2 short-chain PFAS compounds, which were found at elevated levels. This includes perfluorohexanoic acid and perfluoroheptanoic acid. These were detected, the perfluorohexanoic acid was detected in 70% of the samples, and perfluoroheptanoic acid was detected in almost 100% of the samples. And what was really surprising here and concerning is that the levels for the perfluorohexanoic acid were not statistically different from those of PFOA. So this is concerning, because this shows us that now, along with the legacy PFAS, this short chain current use PFAS can bioaccumulate and build up in breast milk at the levels similar to those of the legacy compounds. So along with the short chain PFAS, we also found several long chain PFAS, but their levels were lower. So here I'm showing the estimated daily intakes, or EDIs, which were calculated for the 4 most abundant PFAS which were found in our samples. And this included PFOS and PFOA and the 2 short chain PFAS that I just mentioned in my previous slide. And the EDIs were calculated based on the median concentrations found in breast milk and on the amount of breast milk which is established by the US EPA for different age stages. And here we've looked at the ages less than 1 month old, 1 to 3 months old, 3 to 6 months old, and 6 to 12 months old. And these are established based on the body weight. So you can see here that in general, the EDIs decline, starting from PFAS and going down to perfluoroheptanoic acid. They also generally decline with age, which is not surprising, because the body weight increases with age and the breast milk consumption decreases with age. When we compare these EDIs to the reference dose established for PFOS and PFOA by the US EPA, which is established at the level of 20 nanogram per kilogram body weight per day, we can see that these EDIs are much lower than that. However, now some of the states have established their own EDIs, and here I'm showing the EDI from the state of New Jersey for PFAS, the RFD, and which was established at about 1.2 nanogram per kilogram body weight per day. And you can see that our EDIs for PFAS for all 4 groups actually exceed this New Jersey RFD. In addition, when we compare our EDIs to the average adult intake from the diet, which is shown here, we can see that several of the EDIs estimated here exceed this adult dietary intake. Both of these findings are concerning, because this shows that breastfeeding can be a really significant exposure pathway for PFAS in infants. So here I'm comparing the results in our study with the last study, which was published on PFAS in breast milk collected from the US moms. This was published in 2008. by total. The samples here were collected in 2004. So the table includes detection frequencies and the mean concentrations, which were reported in our study and in this previous study. So we can see here that when we look at PFAS and P4, the detection frequencies are generally comparable. However, the concentrations in our study were lower than this previous study. In fact, they were about 3 times lower, which is good news. The same trend was found for the perfluorohexane sulfonate, which is also considered a legacy PFAS. Our study had higher detection, but lower concentrations of this compound, and higher detection is probably due to the improvements in the analytical methods that have happened since 2008. However, when we look at the 2 short-chain PFAS, which were measured in both of the studies, so perfluorohexanoic acid C6 and perfluoroheptanoic acid C7, these are the same ones which I've described in my previous slides. You can see that perfluorohexanoic acid was not detected in the 2008 study. In our study, it was detected in more than half of the samples at the concentrations, as I mentioned before, quite similar to those of P4. Perfluoroheptanoic acid here in the earlier study was detected in a very low number of samples, about 7%. In our study, it was detected in almost all of the samples and at higher concentrations. So this last group is the long chain PFAS. You can see that some of the trends are the same. For PFNA, the detection frequency in this earlier study is lower. However, the concentrations are pretty comparable. For the other 2 long chain PFAS here, both the detection frequencies and the concentrations are higher in our study. So seeing this sort of different PFAS pattern, which we see in our study, showing that now we see more short chain PFAS in breast milk, we wanted to also look at the global trends and see if we can see any similar trends existing in the available data. So here I'm showing you the PFAS concentrations that were reported on a global scale, and this data is compiled for all the available literature that was published in breast milk since 1996 up to 2009, which is our study. Here, the plot includes China separately and all the countries except China grouped separately because sometimes China has different regulations for PFAS. So you can see here that for both groups, the PFAS concentrations decrease. There is an obvious visual decrease in the concentration starting from 1996 up to 2019, which is really good news. Again, we've done the same for P4, looking at studies from 1996 to 2019. You can see that the concentrations somewhat decrease, but the trend is not as obvious as for PFAS. And in China, in fact, there is no real trend. It's more or less stable. Now, we also wanted to see what are the changes in the short chain PFAS, and here we're looking at detection frequencies. And again, we're looking at all the available studies that measure these compounds. There are less studies because this short chain PFAS haven't been studied as much. And you can see that from 1999 to 2019, the detection frequency for the 5 short chain PFAS that I'm showing here have steadily increased. And in fact, there was quite significant increase somewhere in the last decade. And the detection frequency went up to exceeded 50%. And in some studies, they were detected in all of the samples. So we wanted to know the rate of these changes. And so here we've applied linear regression to the data that I've just shown you. So we've plotted the PFAS, PFOA concentrations against the sampling date, and the same for the detection frequencies for the 5 short-chain PFAS. You can see here PFAS concentrations are significantly decreasing. This is a statistically significant relationship, quite strong. The R-square is about 0.7, and the halving time here is about 8 years. For PFOA, this relationship is weaker. It was statistically significant, but the R-square is only 0.2. And the halving time here is much longer, about 17 years, which is twice as long as that for PFAS. However, when we look at the levels, at the regression for the short-chain PFAS, the trend is opposite. There is an increase. This was, again, a statistically significant relationship, although we didn't have as many points for this plot. The relationship was somewhat strong. The R-square was about 0.6. And in this case, doubling time was about 4 years, which means that the detection frequencies for these 5 PFAS are actually doubling every 4 years, which is really concerning. So when we think about sources for this short-chain PFAS, we know that they've been detected in firefighting foams and in groundwater. And here I'm just briefly showing you the results of our PFAS analysis in drinking water that we've collected in Indiana. And we found quite surprising results, because we see here that those 2 short-chain PFAS that we see in breast milk at elevated levels, perfluorohexanoic acid and perfluoroheptanoic acid, are now detected in drinking water at levels quite similar to those of PFOA and even PFAS. And in addition to this, we also see quite elevated levels for other short-chain PFAS here, ranging from C2 to C5. And these levels are actually much higher than those for PFOA and PFAS. And so the C4 sulfonate is also included here. So these results show us altogether that, this increase in short-chain PFAS is really concerning, and this is something that we need to pay attention to. So what we've learned in this project, that now both current use and legacy PFAS are abundant in milk from the US mothers. And while the levels for legacy PFAS are going down on a global scale, the detection frequencies of current use short-chain PFAS are going up, which is concerning. And we think that consistent biomonitoring of breast milk is really needed in order to be able to detect these changes in exposure patterns, and not only for PFAS, but also for other compounds. So with that, I'm yielding the floor or the screen to Sheila, who is going to talk about breastfeeding and ways to reduce your exposures. Thank you.
So first, I just wanted to thank the organizers for inviting me, and Amina and Erica for inviting me to this project. It's something I've been really interested in for a while. I am a pediatric environmental health specialist, but I also am the medical director for our newborn nursery at the University of Washington Medical Center. And so I do talk to women clinically often about breastfeeding. And so when we try to think about the benefits versus some of the potential harms that could be in breast milk, it's something that I think is really difficult to contend with, but is something that we really need to start discussing more as a society. So I'm going to start with talking about the benefits of breast milk and breastfeeding. I think that the strongest evidence is for immune protection with cytokines and immunoglobulins, which are immune factors that really help protect against infection, and they directly and immediately fight infection when breastfeeding happens. So the evidence really shows that breastfeeding can reduce the risk of ear infections by almost 50% with 5 months of exclusive breastfeeding, or respiratory infections, so 72% with about 4 months of exclusive breastfeeding in infancy. So really strong protection. In terms of neurodevelopmental outcomes, they've seen better behavioral development, including decreased externalizing and internalizing behaviors, which is just fancy words for ADHD and anxiety, increased IQ, and better school readiness have been directly linked with breastfeeding. And then there's some evidence for improvement in allergies, obesity, and gastrointestinal diseases and infections as well over time. And this is all summarized in the American Academy of Pediatrics Breastfeeding and Use of Human Milk guidance policy. So there's also maternal benefits, not just to the infant. There's a reduced risk of breast and ovarian cancer in the future after breastfeeding. And then there's the bonding and emotional benefit. So this is not a direct milk benefit, but the bonding that comes with breastfeeding really does improve both infant outcomes as well as maternal mental health. And right now, the current recommendation from the AAP is to exclusively breastfeed for at least 6 months. And that is the shortest amount of time for which we would see significant benefits in some of the outcomes that we just talked about. So in terms of chemicals in breast milk and health impacts, overall, just taking a step back from the PFOA and PFAS, there are many studies with small numbers of participants that report a variety of chemical exposures in breast milk. But there are very few studies relating these exposures with actual health outcomes. So we know we have some data on exposures and the fact that breast milk contain these chemicals, but we have even less data on how those exposures are related to health outcomes. And I think that's for a variety of reasons. One, breast milk is very hard to collect, especially for a new mother when they're establishing breastfeeding with their baby. Every drop of breast milk is really precious. And so it's way more difficult to collect in research studies. And often pregnancy biomarkers are used as a proxy. So we obtain biomarkers from the mothers from either their urine or serum during pregnancy. But I think we need to remember that newborn and infant exposures are just very different because it's a different developmental time period, a different period of susceptibility. And we do know that early life, especially the first 2 to 3 years, is very important for future life outcomes. So I don't think that we can consider those pregnancy biomarkers as a proxy except for potential exposures to the infant. So in terms of lipophilic chemicals, so those are kind of chemicals that persist in fats in the body. There are studies that report that infants who are exposed to these kinds of chemicals have higher concentrations in their bodies than infants who consume formula. And modeling has suggested a decrease in infant exposures to these chemicals after cessation of breastfeeding because in breast milk, we have very, very high fat content, and that's exactly what we want for babies developing neurologic systems is high fat content. But with that high fat content does come persistent chemical exposure, especially the chemicals like these that persist in fats. And so I saw from one of the Q&A questions, would you have less exposure from formula versus breast milk? And so if you have to think about this kind of in a localized way. So specifically in Alaska, the few drinking water studies that I have seen have either not found these chemicals in drinking water or very low exposures in drinking water. And therefore, if you're using drinking water to constitute your formula, you're likely to have less PFOA, PFAS exposure compared to potentially breast milk. But that's very localized to region. And even within Alaska, it could be very different from region to region. There's very few places where there has been drinking water tested. So in terms of messaging to new moms, what do we what do we tell them? And I think that coming from the clinical perspective, we really don't want to scare people, and we want to give also the best messaging we can with the best science behind it. And I would say at this point, breast milk really is still best based on what we know about immune protection and reduced infection. And breastfeeding is associated with positive outcomes in newborns and infants and also in later life. I think that if we start to see more and more chemicals that affect immune function and immune protection, then that messaging could change in the future. But for right now, studies still find that breastfeeding is related to better long-term outcomes. One thing that I try to tell people is really there is no zero exposure. In our industrialized societies, we just cannot get to zero. We're all exposed to some amount of chemicals. And so really what we want to try to do is work on reducing our overall environmental exposures. And one of the ways, these are a few of the ways that we can do that. One is to try to consume a fresh food diet as much as possible. Frozen is included in there. That's really decreased processed foods. You can see here in this first bullet point that I put fresh and varied food diets. So that variation is really important because, another question that someone had in the Q&A is they're worried about fish consumption. And within Alaska, there have been these chemicals found in fish in certain areas. I think the one that I saw was Kimberly Lake specifically. And so if you consume fish from that lake every single day or multiple times a week, you're likely to have higher exposures to these chemicals. If you can try to vary your diet a little bit more, then you won't have such high concentrations. And so that's the reason for that varied food diet. And that's really for all of us, and not just for the PFAS, PFOA chemicals, but for kind of all chemical exposures through diet. Take your shoes off when entering the home to try to reduce exposures to chemicals. We talked about reducing processed foods when possible, and try to use products in your home low in toxic chemicals. There was the report that just came out about these chemicals in cosmetic products. So I try to talk to people about reducing the number of products that they're using on a daily basis. And I guess, one thing that I want to emphasize is really there are no evidence-based guidelines to reduce exposures at this point. And in other words, there are no studies that show that certain guidance will actually reduce your exposures to these chemicals. So while it's intuitive that, let's say, fish has high concentrations of these chemicals and you reduce your exposure, you'll have less exposure. For using products on a daily basis, or just you're going through your daily life, we have not seen that there are evidence-based guidelines to reduce exposures. And I just want that message to be clear, because I don't want people to feel like, oh, if I can't do this and this, then I'm hurting my baby or I'm not doing the right thing, because we really just don't know at this point. But nevertheless, we do know about these sources of exposure, and it is intuitive that if we focus on those sources of exposure, we can reduce overall exposures in our daily lives. And I think that Amina and Erica have talked a little bit about this, and Erica will talk even more about the stain repellents on carpets, clothing, and fabrics, trying to reduce those, the grease and oil-based packaging for foods. There are some nonstick coatings on pans. This was eliminated, but if you buy from other countries or imported, you still can see these chemicals in these coatings. One thing that can be done is water filtration to reduce your exposures to some of these chemicals, but it's very expensive to do. So I often don't list it, but it is something that has been shown to reduce exposures to the PFAS chemicals.
I'm just going to really quickly run through some of the changes that we need and some of the changes that are already happening, and make sure we have some time for question and answer. So big picture, the changes that we need from the government and market are policies that prevent the use of the entire PFAS class. We need to stop picking and choosing which ones we already know are harmful and allow the other ones to be used. We need to eliminate all of them. And as we do that, we need to know what other ingredients are being used. We can make sure we're moving to safer alternatives. And we need to invest in research that develops those safer chemicals and materials. But we already have PFAS contamination, so we need strong standards requiring testing in the environment and cleanup of PFAS where we find it. And where we have PFAS and we've doing that cleanup, we need to ensure safe storage and disposal of waste that contain PFAS. We have seen in the last several years a lot of shift in the market where retailers are seeing that they need to move away from PFAS. Whole Foods was the first major North American grocery chain to publicly commit, and their action has had a really big impact. We've also seen action from Trader Joe's, Ahold Delhaize. Taco Bell was the first major fast food chain to commit, and they're addressing several chemicals in their food packaging. And then, we've really seen more and more companies make these commitments. Most recent were McDonald's and Wendy's, which have a really big impact because those are obviously really big players. We've also seen regulatory action led locally, so by cities and states, starting with San Francisco and Berkeley, moving on to Washington, Maine, New York, many others. And these have included bans on PFAS in food packaging, as well as bans on PFAS in firefighting foam. And I think most recently we've seen laws passed in Vermont and Minnesota. So this is really, becoming a bit of a snowball effect where we're seeing multiple states take this action. And then federally, Congress has shown some leadership, mostly in the area of firefighting foam, where Congress has directed the Federal Aviation Authority to allow civilian airports to use PFAS-free firefighting foam, and has directed the military to start phasing out PFAS-containing foam. We also have legislators who are introducing legislation to ban PFAS in food packaging and cosmetics. All right, with that, thank you so much for hosting us today. It's really a pleasure to have been able to do this, and we have a few minutes for questions. So I will stop my screen share.
Thanks, everyone. Yeah, it was really a treat to have such a breadth of experience there on this issue. And yeah, some questions have come in. You've also done, I think, a good job of answering some of them as they've popped up. Sort of the theme of several questions around, what preferable foods might there be, or are there particular regions of the US where contamination is more or less likely? Something that just popped into the Q&A here is on bottled water, which is sometimes looked at as a solution if you learn that you have contaminated groundwater in your community. Or is bottled water safe, or is there PFAS in bottled water? Can you comment about this?
Well, I can. Erica, did you want to take that, or I can comment too?
Go ahead, Sheila.
Okay, well, I mean, so a lot of bottled water is just bottled tap water. And so tap water is the same as what you would be drinking at home. So there are a few manufacturers of bottled water that do filter their water with an activated carbon filter, which is really what you would need to reduce these chemical exposures. But I would say the majority of bottled water likely contains chemical exposures that are similar to the region from which you're collecting that water.
That makes sense. Yeah, similar to some of your sources of food, or yeah, other sorts of contamination. Yeah. region to region varies. There's a question here about if there's any intention or plans to, or already existing data on the PFAS levels in the nursing infants who breastfed by your recruited mothers.
No, we did not collect that data. That would be a whole nother project. Yeah, when I was a nursing mom, I was actually part of a study where my breast milk was tested for flame retardants. And then a couple of years later, when our kids were toddlers, they tested the kids' blood for those flame retardants and found that the kids all had higher levels than the moms. But we don't have any immediate plans to do that with this study.
Thanks, Erica. You've touched on this, I think, a bit, but there sort of a question on a lot of people's mind is if a woman finds out she's pregnant and is now breastfeeding, is there anything useful she can do to cut out PFAS to protect the baby, or is it too late because she's likely has been exposed already?
So we really, I want to emphasize that what we need are changes in the marketplace. We need changes in policy because we can't expect women of childbearing age to bear all the responsibility for making pregnancy and breastfeeding safe. But I think the main way that that expecting moms and new moms or parents can try and reduce exposure would be to avoid stain protection treatments in their home. Also we see that there's an association between levels in indoor air and levels in people. And so, ventilation is something we've talked a lot more about during the last year because of the pandemic, and ventilation can also help with these exposures. You can also avoid getting greasy food in takeout containers because that would be more likely to have PFAS.
You can also vacuum more often because dust is also a sink of many environmental contaminants, and in general, more frequent dust vacuuming has been shown to reduce exposures.
Yeah, thank you both. That there was a question there about the comment to take shoes off when entering your house, and I believe that follows on that your shoes are a way to track in contaminants from the outside environment into the home where you spend a considerable amount of time. So yeah, vacuuming or other sort of cleaning is another way probably to contend with that. There's a question I'm not entirely sure I'm tracking it, but I'm going to throw it out there. It's what is known about the level of immunoglobulins in breast milk of highly PFAS exposed mothers?
That's a great question, and it's actually something we've just started to talk about with these samples and with the participants. If we can look at some of those outcomes, but really I have, maybe Erica and Amina know better, but I have not seen any studies of PFAS in breast milk and immunoglobulins.
Yeah, another topic that's come up in a few different ways is if there's any known, cumulative effects. We've heard a little bit maybe about the bioaccumulative nature of PFAS in the human body, but any relationships to other contaminants that we know about in foods or environmental exposure?
I would, we're always concerned about cumulative impacts of these compounds as, one of the reasons that we emphasize prevention instead of risk assessment, because it's, pretty much impossible to be able to really understand what the cumulative impacts on one system are. If we have multiple chemicals that can affect thyroid, neurodevelopment, liver and kidney, we can expect that there may be some cumulative effects. I'm not aware of any specific studies on PFAS, but those are some of the areas that we might be concerned about.
Thanks, Erica. There's a question here as well, but particular to your study, were the participants in the Seattle area, were the mothers from all over Seattle, or sort of in reference to our situation here in Alaska, were they close to airports or like known sites of possible exposure?
So the moms were they were Puget Sound area residents. So, you know, they were kind of concentrated in Seattle, but also from the suburbs and from the counties adjacent to the county that Seattle is in. Very few of them were in areas with known drinking water exposure. Most of them had Seattle area water, which is surface water with no known contamination.
Gotcha. Well, looking at the clock here, are there any final remarks you guys would like to make, or a little message to close with? I have a few words to say just about some going-ons here with PFAS legislation in Alaska.
Well, I would love to just direct people to our website for more information. There's, you know, a link to the study, but also a frequently asked questions and a fact sheet that presents the results in a little more user-friendly way. If you want to share this with your friends. And then of course there's opportunity to take action. And I'm sure that there's some opportunity that ACAT has as well for that.
I was also just going to add that I agree with Erica that the burden shouldn't be on the individual here. And this is a topic that EPA is considering strongly right now. They are coming out with recommendations. So I do think that at the federal level, we are seeing some attention to this topic.
And I would like to ask that, add that I think it's important to consider PFAS as a class of chemicals, because now seeing this different new PFAS shown up in different biological samples, including our breast milk samples, you know, this emphasizes the need to regulate the PFAS as a class of chemicals.
Well, thank you. Thank all three of you so much for joining us. Just have a few final words here. I'd just like to mention that the Alaska State Legislature has considered two bills on PFAS in the 2021 session, House Bill 171 and Senate Bill 121. And each would require greater protections for communities by preventing and addressing PFAS contamination, including setting enforceable drinking water standards for a number of PFAS, as well as requirements for polluters to pay for safe drinking water and blood tests for people affected by PFAS contamination. These measures are urgently needed, and so we ask Alaskans to reach out to their legislators to pass these bills. They'll be looking into it. It'll be on the floor, hopefully in January 2022, in the second half of the session. And there's opportunities to support legislation at the federal level as well. So urging our members of Congress to address PFAS as a class, as Amina said, and phase out these non-essential uses of PFAS, replacing them with safe alternatives. Yeah, feel free to reach out to us here at ACAT if you'd like to be involved to establish these protective policies. We'd welcome the support. And yeah, before we say farewell, I just want to thank everyone who joined us today, our speakers, all of our listeners, and I'll send out an email within the next day or two with a link to the recording of this hour we've spent together, as well as a few additional related resources that popped up during the presentation. And we've got a few questions that we didn't have time to get to, and so answers to those if we can track them down. So yeah, our next call will be scheduled for the end of July, hopefully on the topic of marine microplastics, and more details to come there. So if you can, please donate to support these J-Alaska webinars and ACAT's other efforts. And any additional questions or comments, feel free to reach out to me directly by email or by phone. Our office here is 907-222-7714. Thanks again, everyone. Really appreciate your time and energy. And yeah, I hope you guys have a good rest of your day.